Thank you, Alyssa, and thank you for having me here. And I hope you will agree that this is the light, there is light here. And I do think there is. So before I get started, let me just thank the students and collaborators and funders who really made this work in research possible. One of them is Joel Chan, who's sitting right. Joel, can you wave over there? Joel, hi, Joel. So we're here to talk, as Alyssa said, about creativity and collaboration. And if we ask, what is it that humans are uniquely capable of that enables us to do this across art, science, engineering? One answer that I like a lot from Castells is that we're able to creatively accumulate and recombine knowledge and information in non-routine ways. And let me emphasize recombine, because I think that's key. I think it's really important because many discoveries and innovations have been made by analogy, have been made by taking ideas from one field and recombining them with another field. So more than 2,000 years ago in science, we have Chrysippus, who understood the functioning of sound waves by analogy with water waves. In art, Leonardo's Vitruvian Man was based on an analogy with the perfect proportions of a Greek temple. And in engineering, the Wright brothers used multiple analogies to figure out how to steer their aircraft, including balancing it by analogy to riding a bike, and moving the wings by shearing them, which was actually a very simple technique compared to some of the more engineered techniques, and that was inspired by an empty inner tube box sitting in their office. More recently, we've seen a very different kind of innovation emerge, and here's an example. This is the Odon device, which is a way of safely removing a baby that's stuck in the birth canal. And this is touted by the World Health Organization as one of the most significant advances in childbirth in centuries. Now, what's interesting about this, I think, are two things. So the first is that it was not invented by an expert in childbirth. It was invented by Jorge Odon, who is an Argentinian car mechanic. And second, the way he was inspired was by watching a YouTube video, which was a party trick about how to extract a cork stuck in a bottle, okay? So what I think this is pointing out is that with the internet connecting us, connecting ideas, we have billions of people who could collaborate to find analogies, and we have billions of inspirations from which to draw them, with repositories of ideas including innovation contests, patent databases, YouTube, and the internet more generally. This combination of access to billions of minds and billions of ideas has the potential, I think, to launch us into a golden age of innovation and make progress on society's thorniest problems. But there's a challenge in making this a reality, and that's one that all of you have experienced, which is that it takes a really long time to investigate a single field, let alone the multiple fields you need to find innovative analogies. And probably the best example I have of this is illustrated in analogy by Matt Might, and this is about getting a PhD, but insert your own graduate degree or specialty here. So imagine a circle that contains all of human knowledge. By the time you finish elementary school, you know a little bit. By the time you finish high school, you know a bit more. With a bachelor's degree, you gain a specialty. A master's degree deepens that specialty, and reading research papers takes you to the very edge of human knowledge. Once you're at the boundary, you focus. You push at the boundary for a few years until one day the boundary gives way. And that dent is called a PhD. So getting to the edge of one field is hard, but if we go back to history, like I said, many important breakthroughs come from bringing together ideas from different fields, like between sound waves and water waves. So how could we expect to do this when it's so hard to learn even a single field, let alone look through the multiple fields you'd need to to find them. And information's growing, right? So it's taking longer and longer and longer and longer for any one person to get the edge of any field. But if you look at our brains, our ability to learn information has not really kept up. It hasn't significantly changed since at least the time we diverged from Neanderthal. And I've put the most evolved person I know on the right side here as contrast. So how do we solve this problem, okay? So I think that we need to go beyond thinking of analogy as the province of a lone genius who's struck by lightning in a eureka moment, okay? Instead, what we've been exploring in our lab is how can we take this process of analogy out of a single person's head and distribute it across many, many people. And I'm going to do a little audience participation here just so that you can understand this process, and then I'll describe it a little bit more. So bear with me here. So, this is a rake here, and it's got this little thing on it, and if the leaves get stuck, you can push the leaves off, okay? Now, here's a skewer, and if you get your food on it, your barbecue skewer, you can grill it, and then you can get the food right off of there, too. So if I asked you, what purpose and mechanism are these two things using? What do they share? So think to yourself, what purpose and mechanism do these things use? So you might say, they detach two objects using a movable slider. Okay, so this isn't about food anymore. It's not about leaves anymore. We've sort of gone up a level of abstraction here, and we're able to say, what's the purpose and what's the mechanism? And now we can use this, right, by transferring to a new domain. So we can say, in what other situations might you need to detach two objects from each other? Okay, so any ideas? Where else might you need to detach two objects from each other? Baby from uterus, excellent. What was the other? Oxygen and hydrogen, excellent. Say it? Oh, deep. And so now you can take those ideas and we can use that was our purpose, we can use our mechanism now to say, can you solve this problem using a movable slider? And so some of these things might be, in the case of the uterus and the baby might be more amenable than others. Here's, you can take your own idea and see if you can apply this mechanism to it. Here's one that was actually developed. This is a knife. If you get your garlic stuck on it, you can slide it off, okay? So just to give you the flavor of what is happening here, this is actually a very common process and very well known based on models of human and analogical processing. And they all involve this common process of taking an example, abstracting. In our case, because we're interested in products or innovations, we're abstracting a purpose and a mechanism. We transfer that to a very different domain, and then we can generate new ideas within that domain. Now, in our process, what we do is we separate those because they don't have to necessarily happen in a single person's mind. What if different people were involved in different parts of those processes? What if they were emitting these to each other so that we could capture them, we could prune them, we could direct them, we could understand them, we could filter them, right? What can we do if we can aggregate them? So there's a lot of things that you can do once you start to take analogy out of a single person's head. And I'm going to show you how this simple idea addresses three keys to scaling serendipitous analogy. The first one is fixation. So this is a huge problem in art and science. Seeing an example, instead of inspiring you, can often fixate you. It can lead to conformity effects, homogeneous ideas. And this is a very unconscious process. So if I think about the example of, don't think of a white elephant, well, that white elephant is activated in your head, no matter what you try to do. So this is a problem when analogy happens in a single person's head, because they know what the base domain is. They are going to be activated. They're going to be fixated on that domain. But if different people are involved in different parts of the process, maybe we can get around that. Okay, so before I show you the results, let me just say, we've done a number of experiments looking at this. I was just over lunch talking to someone here who was asking, well, how do you even measure creativity, or the quality of a creative idea? And there are decades of papers looking at this, and it's a really hard question. But overall, what people have come to is this idea that we can measure creativity in terms of the novelty and the usefulness of an idea. And you put those together, and you get a measure that we are just going to operationally call creativity. That's what I mean by creativity. It doesn't necessarily mean that if something scores high, it's really creative. What it means is that the difference between two items tells us something about how creative in this measure we call them. Okay, so that's a tiny digression there, but that's what's on our y-axis here, is the creative quality of these ideas measured by their novelty and usefulness. And what we find here is that compared to instances in which people see the original domain, they see the original examples, if we separate the process of analogy so that a different set of people are only seeing those purpose and mechanism schemas, we see significantly greater quality in terms of their creative ideas. And these are, again, by judges blind to which condition the ideas came from. Just to give you a flavor of the kinds of things they're coming up with, here's an example of one of these ideas. It's a lens cap inspired by a vegetable steamer. And so, when your camera is off, it's closed. When it's on, it opens and acts as a lens hood. And as a failed photographer myself, I kind of really want to have something like this. Okay, the next challenge is expertise. So the examples I showed have been kind of toy or consumer level problems. And so to look at how this works for innovation in the real world in more complex settings, we've been working with R&D professionals looking at their own problems. And today we're seeing two main approaches to innovation in R&D. In-house R&D teams, which is kind of the very common and traditional way of doing it, have expertise. They have a lot of context with the business problems, their market, and what they're trying to do. But they're limited in terms of how much they can explore, how much time they have. They have fixation on the types of things that they know, they already know well. Meanwhile, we're also seeing increased use of crowds, primarily through contests, which have, as you've seen with the Odon device, led to some remarkable outcomes. But as people who are running these contests are increasingly experiencing, crowds can lack the expertise, they can lack that context, which will allow them to solve some complex problems on their own or make those outcomes very useful. Another big problem with contests is that they're really inefficient. So you have 99% of people who participate, they don't get rewarded at all, and their work is essentially discarded. So we thought, instead of each of these working individually, what if we could take this idea of distributing the analogy process so that each of them is working in the most appropriate part of the process? So we can have crowds which are going out, expanding, looking for ideas, maybe unfettered by some of the fixation that the R&D experts would have, and they're providing those as inspirations to the R&D professionals who have that context and expertise to apply them to their own domain. So when we do this, we found that R&D professionals who were given inspirations from others, these are the two bottom rows, the distributed condition, especially in the distributed analogical condition, generated more high novelty ideas than those working individually, okay, those working alone. And so we still have work to do here. This is in process to follow up on this, but it suggests a new type of collaboration at scale that might be more efficient and more inclusive than either group working alone. Okay, the third problem I'm going to talk about is one of scale. So with billions of potential problems and solutions, even crowds are not going to be large enough to sort the useful ones from the less useful combinations. So we need something else. We need some computational tools, at least to do a first pass. And it doesn't have to be perfect, but it does have to be fast, it has to be cheap, and critically, it has to find things in different domains. It has to find things across the surface features of one domain to find something that's structurally similar in another domain. And even if we can get a small improvement here, we could get kind of very large benefits. So the problem is that machines have a really, really hard time with this, and they have had a hard time for decades. The two big approaches that have been used are to either handcraft representations, which is what kind of people do on the left. People will sit and handcraft these, and they are actually very effective. They're very good at finding deep structural similarities, but they're really expensive. So it can take up to 40 hours to craft, for some complex products, a good representation. So that doesn't scale terribly well. An alternative is to use current AI or machine learning approaches, which are fast and cheap, but they're very influenced by the surface features. They're looking at co-occurrences across words and embedding those in spaces where those co-occurrences have meaning. So let's apply our idea of distributing analogy to this problem. And the insight that led us to is that for a cheap and dirty first pass, all we really need is to be able to separate that purpose and that mechanism to enable that first part of the process, and the rest of it we can give to a human. And so what this assumption makes possible that wasn't possible before is that we can use the fast and cheap machinery of AI and machine learning, but because we've separated those mechanisms and purposes, we can look across domains by saying, find me something with a similar purpose, but find me something that has a really different mechanism. It looks really different, even on the surface, than what I had before. So I'm not going to go into the details here, but we use some deep learning and word embedding techniques. So think about the kinds of things that Fernando was trying to visualize yesterday. We're using those types of approaches. And the intuition is that we're training purpose and mechanism detectors, right? So the output here, so the input is a product. The output is a purpose vector and a mechanism vector. And now we can do exactly what I said. We can look for ideas that have a similar purpose, so trying to separate two objects, and are very different in terms of mechanism. So maybe they're not looking at using a movable slider, they're sifting, or maybe for hydrogen and oxygen, maybe they're distilling or some other type of process like that. Okay, so I'm going to wave my hands vigorously and not show you any math, but you can read this paper for more details. And when we gave these as inspirations to a group of people and we said, hey, come up with new ideas, come up with as many new ideas as you can, what we found was that those given the analogies found by our system had a significantly higher proportion of good ideas, again rated by multiple blind judges, more than twice as many on average than either the surface or the random conditions. Okay, so then we said, well, okay, why is this happening? Let me give you an intuition around what is happening here. Let's look at an example. Let's say we wanted to find inspirations for designing a cell phone case that also charges your cell phone. So if we use standard information retrieval techniques, we get back things that are really relevant. These are very relevant to designing a cell phone case. But they look like cell phone cases, right? These are cell phone cases, so they're not terribly inspirational. If you give people random things, then you get back things like shampoo pods or dog meetup app. And I know you will, because I have done this before, I know you will find a link between shampoo pods and cell phone charger cases as you stay up tonight or tomorrow in the shower or something, because you will find some link there. But it's hard, right? It's hard. Or for the dog meetup app, it's hard. So these are very diverse, but they're not that relevant. Now, in our approach, what we find is that we get things that are from very different domains, but they have structural similarities with what we want. So think of, it's a little bit silly, but the human pulley-powered generator suit. This was an actual idea in the corpus that we were looking at, and that inspired a number of ideas that happened to be about powering through the kinetic movement of the human. Okay. And now we're following up on these results. We're looking at other domains. We're looking at finding analogies between scientific papers in different domains. We're looking at connecting research and product groups in companies which have a difficult time making that transition. And what I want to leave you with is really this takeaway that we need to go from thinking of innovation as something like lightning, something that's random, individual, something that's very rare, to something like a power grid, right? Something decentralized, persistent, ubiquitous. It's always around us. And we've seen the power of building networks before. When we built a highway network, it transformed our economy. When we built a power network, it transformed our economy. And I think that if we invested in building an innovation network, it could also transform our economy. Imagine a massively collaborative, persistent, and robust network for accelerating innovation. So let's end back with Castells, and now I'm going to focus on a different word. I'm going to focus on the word non-routine. And I think this is important because in the next 5, 10, 20 years, AI and robotics are increasingly going to take over the work that is routine. And we need a channel to take that human ingenuity that is freed up, and we need a place to put it. We need a way to channel it into doing non-routine work, to accelerate innovation. And I really do think we don't have that much time before millions of people who, since they're age 4 or 5, are able to make these deep analogical connections, which are really hard for machines to do. How do we tap into that and channel that in a way that's going to help everyone? Can we create an infrastructure for innovation that can involve and benefit everyone? Thank you.